Now that we've discussed binary addition, let's see the rules for binary subtraction. First, let's do the easy base cases. So this is easy. 0 minus 0 is just 0. 1 minus 0 is 1. 1 minus 1 is 0. This all looks the same as subtraction we've done in decimal. But the next case is 0 minus 1. And so what should this be? So let's just revisit how we would do a subtraction problem in decimal. Decimal subtraction, i.e. if we had something like 23 minus 18. So the algorithm here is we look at this first column and we see that 3 is too small to subtract 8 from. So we back up one column here and we're going to borrow a 1 from this 2. So if we cross that out, we put a 1 instead, and then the one that we borrowed we put right in front of the 3 to make it a 13, and then 13 is big enough to subtract 8 and we would get 5. We move over a column, 1 plus 1 is 0, and this is how we're able to do a problem like this. So we're actually going to follow the same process when we're doing binary subtraction. We are going to need a borrow bit in order to subtract a larger number from a smaller number. And when we do that, that borrow we're going to put on this 0 here, making it 1, 0, which as you guys know is 2, so 2 minus 1 is 1. So the way we would label this is 0 minus 1 is 1 with a borrow of 1. Okay, or sometimes you might see it as just a B. Okay, if you see a little C there, that means a carry. If you see a B, that's for borrow. So let's see an example of how this works in with a bigger number. So let's subtract 1, 0, 0, 1 and 1, 1, 1. Okay, great. So what we're going to do is we're going to stack them up just like we would do if we were doing a subtraction problem in decimal. 1, 0, 0, 1, 1, 1, 1, and subtract. Make sure to write justify, so make sure that the least significant bits of both numbers are lined up. And then we're just going to go column by column and subtract straight down based on these general rules that we wrote up here. So 1 minus 1 just gives us 0. 0 minus 1, 0 is too small to subtract 1 from, so we're going to need a borrow. So we look to the column in the left, there's no borrow available, so that means we have to look one more column over. So we're going to borrow a bit from this column. So we put a 0 here. That 1 we put to make this a 1, 0. Now this is a column we actually need the borrow in, so it means we're going to borrow from this number that we just created. 1, 0 is 2 in binary, so that means if I borrow 1 from 2, I'm going to be left with 1. And now I take the one that I borrowed and I put it in front of the 0 to make this 1, 0. 1, 0 is 2. 2 minus 1 is equal to 1. Great, and then I just continue on to the left. 1 minus 1 is 0, so my result of the subtraction is 0, 1, 0. So we can check this in decimal. So our binary number, if we were to convert that to decimal, 1, 0, 0, 1 is decimal 9. 1, 1, 1 in decimal is 7. So if we did this subtraction problem in our native decimal number system, we would expect the answer to be 2. If we convert this back to binary, we get 1, 0. And this indeed is what we got from doing the binary subtraction. So let's see another example, example 2. What happens if we end up subtracting a larger number from a smaller number? I.e., let's do this one. How about we do 1, 0, 1, 1 minus 1, 1, 0, 0. 1, 1, 0, 0 is bigger than the first argument. So if we stack these up, 1, 0, 1, 1 minus 1, 1, 0, 0, and then column by column we just go through and subtract. 1 minus 0 is just 1, 1 minus 0 is 1, 0 minus 1 is going to require a borrow, so I'm going to borrow from this column. That's a 0. This makes it 1, 0, which is 2 in binary. 2 minus 1 is 1. And now I have a 0 minus 1, but I have no more borrows available. So this is going to be kind of my extra borrow bit that I need to tell the user that I'm going to require in order to do this binary subtraction. So if I do borrow this bit, I'm going to cancel this out and make this a 1, 0. So this result ends up being 1, 1, 1, 1 with a borrow of 1. Okay, so I can check this just like I did in the previous problem. My binary number 1011, the decimal equivalent of that is 11. And then 1100, the decimal equivalent of that is 12. And then if I subtract these numbers in decimal, I would expect the answer to be -1. The answer I got in binary was 1111 with a borrow of 1. It turns out that this is actually -1 under 2's complement convention representation of a negative number. And actually what we're going to talk about next is doing subtraction using complements, because if we can change any subtraction problem to an addition problem by adding a negative instead of subtracting, then we don't have to deal with this confusing borrowing situation. So we'll talk about that next.